issue with straightforward concept.
The limit doesn't exist outside of continuous.
No, the limit of sine 1 over x doesn't exist.
No.
But the limit of x sine 1 over x does exist. And it's 0. So the function is continuous from the right. So now that it has, now that it's continuous, is this different? Well, here, x cubed tau of x. If x squared tau of x is differentiable, not necessarily continuously differentiable, just differentiable too, then I'm allowed to use the product rule on x cubed tau of x. And the derivative would be 3x squared tau of x plus x cubed times the derivative of whatever we find this to be. Okay? This is existing, and all these exist. So that's why he went up to the cube. We can differentiate the cube if we can show that x squared tau of x exists. So great, how do we do that? Well, we form the derivative, difference quotient, see what happens. I would like to show that x squared tau of x prime exists. How do we do that?
Don't you not need an x squared there?
Where? No.
Using the product rule of x cubed tau of x. Sorry, it's not.
No.
There we go. Now we're happy.
All right.
Well, I'll tell you, let's just attack this head on. Does the limit as x goes to 0 of write down the easiest definition of derivative here. X is this is the point x naught. So what I'm going to do is write 3x. Sorry, I'm going to write x cubed tau of x minus x sub 0 cubed tau of 0 over x minus x 0. Okay? And fill in the blanks. That's the limit as x goes to 0 of x cubed tau of x, that's 0, over x but that baby's going to have a limit, namely 0. So I think the derivative of the function that he is writing down there in exercise 2.3.2 is actually 0, at 0. And then when we're not at 0, so he's calling it f of x, is this function. X cubed sine pi over x between 0 and 1, 0 not included, and 0 at x equals 0. So I'm claiming that f prime of x is going to be 3x squared sine pi over x plus x cubed what the hell is it? Pi cos pi over x times minus 1 over x squared, right?
Over x squared. Okay.
Be
Chain.
there, and then 0 and x equals 0. To show that this function is integrable, I have to show it's continuous. So if I simplify this, I'm finding that f prime of x, that's something, yeah, calculate f prime. This is part A we're doing. So what's f prime? It is 3x squared sine pi over x minus pi x cos pi over x. See? So this is the usual condition here between 0 and 1, 0 excluded. All right, so that's part A. Got it. Is that function continuous? If it's continuous on the closed interval 0, 1, then as weird as it is, it still has a Cauchy integral. Is that continuous? I would say so. The sine and cosine are both bounded functions, and there's an x in front here. So if I just stay real close to 0, x stays real small, and it doesn't matter what the sine and cosine are. It pulls everything else down, right? Right? You're buying that? We don't need to do an epsilon delta there, right? Yeah, that would be a nasty epsilon delta. Well, not really. You just say these things are never greater than 1. And then given epsilon, what do you have to do? You have to get 3x squared minus pi x. Well, this thing can oscillate, so absolute value 3x squared plus pi x, keep it less than this. And you'd find that that was doable. So this function is continuous. Hence, what? It is a Cauchy integral. And, okay, we just did part B. And part C, the Cauchy integral would be what? Well, we just proved the fundamental theorem of calculus, Cauchy style, and it would be f of 1 minus f of 0. So the integral from 0 to 1 of this goofy function is going to be the integral evaluated at, or the original function f evaluated at 1, which is x cubed is 1, sine of pi is 0, right? So it's going to be 0 minus the function at 0, which is 0. So I think the Cauchy integral vanishes. Anybody see anything wrong with that? So that's a horrible function. You don't want to give the calculus students, though. Right? Yeah, they'd be staring at that one for a while. Oh. You see that little trick, though? X kills everything, so even if you have a very poorly behaved, bounded function, we could probably dream up there. If you have a function that's bounded in the neighborhood of 0 and multiplied by x cubed, and as horrible as it is, it's differentiable. If its derivative is continuous at 0 and it's Cauchy. How about the salt and pepper function? That has some other stuff built into it that's bad, but if you took the Dirichlet function, one, if x is not rational, and 0 if x is rational, and multiply that by x. So let's call this the modified Dirichlet function. Is continuous at 0. Think about that. What do you think? Continuous. Huh? Yes, I think it is. Why?